Hello YouTube, it's Sumner, and today we're going to be working on some Advent of Code for 2019. I've done the first 11 problems, as you can see, and I did the first part of 12, but the second part requires me to do some sort of optimization to make it more efficient, and I don't want to do that right now, so we're going to just move on to day 13 and go from there. So I glanced over this project problem earlier, but I haven't really read it. And it looks like we're in space. We have a 3-hour round trip for messages between Earth and ourselves. That's a pretty quick round trip. I guess it's speed of light, so we're pretty far away, actually. This is quite a few astronomical units. I think it takes about 16 for a round trip to the sun and back. Okay. So we have a mail indicator. They sent us a care package. And it's a new game for the ship's arcade cabinet. Oh, of course we have an arcade cabinet. What's this link? Oh, it's just to the arcade cabinet. That's boring. So instead of going to our arcade cabinet, we're just going to make our own arcade cabinet, I guess. Yeah. So we're going to run an Intcode program, and it has a primitive screen capable of drawing square tiles on a grid. Okay. The software draws tiles to the screen with output instructions. Every 3 output instructions specify the X position, the Y position, and tile ID. Interesting. So the ID, okay, so these are the identifiers. So 0 is an empty tile, wall, block, horizontal paddle. The horizontal paddle is indestructible. Oh, this seems like pinball. Okay, so a sequence of output values like 1, 2, 3, 6, 5, 4 will draw a horizontal paddle. Okay, so that's 3 at 1, 2. And 6, 5, 4. So 4 is a ball, and it will be at 6, 5. How many block tiles are on the screen when the game exits? Okay, so first things first, let's figure out how to read this stuff in. That's 12. I don't want any of that. I'm doing this in Python, in case you couldn't tell. And we're going to do, so this is, I guess, just our program. And tape is what I've been calling any of the other ones, and I'm just going to copy from, I think 11? Yeah, here we go. Let's copy our in-tape reader. And then let's just grab all of our Intcode interpreter. I think this is a good time to just take a brief break and talk about how my machine works. It's, I think, pretty cool. So the first thing that we have is a class tape. Basically what this is it's a glorified array. It literally is just a list underneath, and then the get item and set item attributes are overridden. So that we can index into the tape at any point and it won't explode. I guess if it's negative then it will explode, but so for example, like here, if the index that we're trying to get is an integer, then we just either return it or return 0. The 0 case is the case that we have an item which is outside of the range, and they're by default 0. And then we handle ranges as well, because that's necessary for some of my code. Pretty much the same thing here with setItem. If it's too long, we just extend the tape further with more zeros, and then set the value. So that's the tape class. There's nothing else interesting there. The machine is what is pretty interesting. So the machine is a function. It's a generator function. It generates outputs. So to receive the next output value, you just call next on the machine generator. Inputs is an iterable of inputs. So you can pass this a list, you can pass this a generator, you can pass it an infinite generator, for example. And I convert it to an iterable just to make sure that we can use it as an iterable. And then down here on opcode 3, which is the input opcode, I use next on inputs to get the next input. So I think this is a pretty good way of doing it. Okay, so back up here, the machine, we have a program counter. That's the instruction pointer, I think, is what the nomenclature is in the problem. We also have our relative base, which is exactly what it says it is. And then, again, the inputs is an iterable. My instruction decoding is here. Basically, I take the opcode mod by 100, that's the, or the instruction mod 100, that's the opcode, and then the various modes, where we have, we're just reading in the digits of I over 100, integer mod, oh my goodness, integer divide 100, and then we're just getting each digit by doing the classic mod by 10, and then divide by 10, integer divide by 10. So that's our instruction decoding, and then get value. This takes into account the mode, and then gives you, really shouldn't be index, it should just be like, you know, because it could be the index, or it could be the immediate, or it could be the offset. But I called it index, and this basically handles the modes. Set value is the same except for setting, and mode 1 doesn't work for set values for the destination parameters. So then I just have a while true, and we decode the instruction at the tape position, and then we we'll just go through all the different opcodes and figure out which one we want to handle. Addition and multiplication are here. They're pretty simple operations. We're using get value, we're using our nice tape accessor function, and then we're just multiplying and setting it. And opcode 3, same idea, we're just setting the value except for getting it from our input. Output is a yield, so this is what I was saying, this is a generator function. So when we yield this value, then the program basically, or the function stops, yields that value out. You can handle it from the caller and then return back in when you call next again. Opcode 5 is just a jump, and we change the program counter. All these are pretty standard. You know, we have the not equal to 0, equal to 0. We have all this less than equal than stuff. Honestly, not a ton that's interesting for that, and again, relative base, we've updated that with opcode 9. I guess one interesting thing about this is the fact that we're setting local variables to this function, and we can do that because this is a generator function, and the generator function keeps its context, keeps its stack and everything, stack variables, through its multiple calls, or multiple resumes, however you want to think about that. And then at the very end, we have some error handling. This, errors don't ever really happen, or they shouldn't happen. So we always exit if they do. And then we have a PC incrementer. Okay, so that is the machine. Let's go back to the problem. And I guess we just need to read in all of the world objects. Yeah, okay, so we need to run the machine. How do I call these things? I gotta look and see how I've called them in the past. Where is the machine? Oh, run painter robot. What does this thing do? Oh, we have to wrap it in tape. Cool. Okay, so there are no inputs, so we're just gonna do a one tuple, or let's do an empty list. That'll work. And print outputs. Let's see what this does. Oh, I need to import this. Any other imports that I'm missing? I don't think so. So let me open up another terminal here, zoom in so you can actually see it. And make that 13 executable. Oh, I need to actually add the puzzle input. That'd be important. This looks like a ridiculous program, actually. Looking at this program, it's kind of interesting. I have a feeling that we're going to hit a 99, that there's some sort of, and then some of these are just program data. That's my hunch. I guess I should probably make a decoder for these things, like to disassemble the Intcode. That'd be kind of fun. Okay, so let's run 13.py. Did I mess up? Oh. Whoops. Oh yeah. Wait. There's multiple lines here? Is that supposed to be a thing? I don't think so. I'm gonna zoom out really quick. A lot. Oh, I pasted it in twice. That would be the problem. Okay, so let's run this, and we have all of the outputs. And really it's just that divided by 3, like, I think, because each thing, each entity is 3 wide. That might not be the case, but we'll just see. Wow, I am bad at Python. And of course we can't, because we need to do the over 3 outside of the len. And listify the generator. And let's just do the inner divide for the sake of it. 805. Let's just see if this is right, and if it is, we'll be golden. Okay, cool. So I think we have to deduplicate. So I'm going to pull in another thing that I did in a previous problem, which is a chunk function. And looks like I did an 8. Basically, this takes in an iterable and then yields containers, basically lists, sets, or tuples of the of n size, of size n, of the iterable. So for example, if you have a list of 10 things and you do chunk of that list and then 2, you'll get like the first 2 values, the second 2, the third pair. So I'm going to just add that in up here. I think that's going to be necessary here. So we're going to chunk n equals 3. So this should return an iterable, I think. Oh, I need to print. Yeah, so this is a generator. Let's just listify it. And there you go. We have all of our entities, I guess, is what it is. And empty tile, wall, block, horizontal panel, wall. Oh, how many block tiles? Oh, I feel really dumb. I thought it was just like blocks were like the things, the grid blocks. Okay. So basically we need to count the number of 2s in the second position. Okay, I feel really dumb now. X, Y, and then ID. I'll just say I, and this whole entity iterator thing. We need to, if I equals 2, count plus equals 0, count plus equals 1, print count. That should be fine. Let's make this, well, let's just make sure that this actually works, and then we'll make it more Pythonic. Okay, 280, that sounds like it's less than whatever I got. Okay, so continue to part 2. Before we go on to part 2, I want to make this a little bit more Pythonic, and do a print of sum of 1 for x, y, I in this whole chunk thing if I equals 2. And I think that should give me the same answer. Yep. And that's way cleaner. And, well, I think it's cleaner. Maybe it's not. It looks like it's cooler, at least. Okay, part 2. The game didn't run because you didn't put in any quarters. Unfortunately, you did not bring any quarters. Memory address 0 represents the number of quarters that you have been inserted. Set it to 2 to play for free. Okay, so I'll just do that immediately so I don't forget. And intape is a tuple, so so take all of the ones past the 0th index and then just append 0 to the front, I guess. Or this has to be a tuple. I think you can do tuple addition, right? Let me just make sure. Yeah, cool. Let me just confirm that this is correct. Okay, so intape was 1 originally, now it's 0. Oh wait, no, set it to 2. Set it to 2. Good grief, Sumner. And we have a joystick that can move left and right. The software reads the position of the joystick with input positions. Input instructions. Interesting. Oh, you know what? Let me look at this input again. Something tells me that, like, there's 2 different programs in this, and then this one does some sort of jump to the correct program. Like I said, I really have to make a decoder for this thing. That'd be a lot of fun, actually. Okay, so this joystick thing has some input instructions. And then, so we'll probably have to keep some sort of state about the joystick. We have a segment display. When 3 output instructions specify -1, 0, the 3rd output instruction is not a tile. The value instead specifies the new score to show on the segment display. So we get -1, 0. So the 3rd output instruction is not a tile. Oh, okay. So if we see something like that, then that's their current score. Beat the game by breaking all the blocks. What is their score after the last block is broken? Oh, so it sounds like we have to, like, actually make this game ourselves. So we've set it to 2. And I guess we should probably figure out how to print this board out. That was probably what I was supposed to do in part 1, but I didn't, so here we go. Let's start by making a board. And maybe this is more like a game, and then we have an initializer that takes in the machine. Or tape, let's do that. And then or I guess it's just the code. Chunk the yeah, let's take in the machine. And then here, what we'll do is we'll do a game with machine, tape, and tape, and that thing. I guess we should probably make this not mutable. Let's just pass it straight in. And then we have our I guess that's what we have. No, I guess we really need to have we need to have, I guess, the chunks in the game. So game instructions. So my idea here is that that we basically have an instruction set on top of the instructions that were already provided. I think. Run. No, I think this is going to be a generator function as well. I think that's going to work the best here. Because then I can do I/O. Because we can take in the machine, and the inputs like that. Honestly, do we even need it to be a function here? Yeah, we do, because we need to translate the joystick position data into inputs. And we need to do outputs. Can't we just do this in a while loop? I'm getting pretty confused. Let's just run the machine to start. And do print of the list. So as you can see, I don't really know what I'm doing here. Oh, I need inputs. We'll just pass empty array for now. Okay, cool. Yeah, that makes sense. We're expecting some sort of input. Let's just we have a run stood out machine that I made in 9, so we're gonna piggyback on that. And basically, what it does is it takes in inputs from wait, where'd it go? Oh, that's not what I wanted. That's a standard out machine. I wanted a standard in machine. I don't know if I actually have that, so guess we'll take that anyway. And let's convert this to just taking a tape. And the inputs will be a generator of iter tools.repeat input. So this is kind of a fancy little trick. I think, honestly, I can just do the input here, and then just iter tools.repeat 1 or something. I think that'll work too. Iter tools.repeat will just continue yielding that value indefinitely. I need to actually run stood out machine, and let's rename this run stood out machine. Yeah, that sounds better. And then we'll pass in this tape like so. And okay, cool. I see. Okay, excellent. So we're printing the output, and now this really becomes a what does it become? Well, let's just begin by thinking about this. Basically, whenever the machine waits for input is when, I guess it's when we, so I guess when, yeah, when does the machine wait for input? It waits when, perplexing this is. Okay, yeah, this isn't going so good. Let's just print the board. I think that's going to be the best place to start. Yeah, I'm not entirely clear on how we're gonna. Oh, maybe I could do some state setting in here. Yeah, that's what I'll do. I'll do that. Basically, I'm trying to figure out when we know how, whether or not we have to have input or output. So print board. Well, how big is our board? Do they say? Looks like no. Great. So I guess we just have a entities map, I think. And we are going to chunk this with n equals 3, as I said earlier, except for this time for real, hopefully. And we're going to do the same x, y, I thing. And this time, though, entities at x, y is what we're going to be setting, equals I. I think that's going to look better, yeah. So how do we know when to print? I guess maybe we just say, like, here the input is actually going to do something a little bit more. Print entities and wait for input. This is kind of a long function name, but I think it works. So we're gonna do more than just that in a minute, but let's just make sure that this mechanic kind of works. And again, we're gonna have to do that. Int argument must be a string of bytes like. Oh, we need to actually call it. Okay, that seems pretty good. I have some grid printers elsewhere. So let me just go find that grid printer. I think there was a min somewhere. Yeah, 11. That sounds right. Let's look at this. Yeah, this is the yeah, we had the board thing. And then we printed the board like this. So let's just do that here. Because we need to know the min x, min y, so that we can print it in a grid, I guess. And x is going to be the map lambda x. I guess looking through this, we have entities. So it's going to be lambda e. Oh wait, no, so this is going to be the key. So it's going to be the position, p0 for entities.keys. Y is just going to be the same thing except for the position 1. And then entities XY. And I think here we actually need to clear all the entities. I don't know though. And also, what is this error that it's giving us? It's saying, wait. I have to do .clear instead of setting it again, because if I set it to empty dictionary, then it'll think that this is a local variable, and this exploded. Okay, so then these are gonna have to change. The 0 is the same, empty. 1 is a wall. At seems fine for that. 2 is a block. What's the difference between a block and a wall? Walls are indestructible barriers. Block, whatever. 2 is gonna be an X, I guess. Yeah, maybe those are my targets. What does it actually say I'm supposed to do? Oh, I'm supposed to break all the blocks, yeah. Yeah. Horizontal paddle. 3 is going to be, we'll do an equals. That seems like a good paddle. And the ball is going to be 4, and that's going to be an O, I guess. Yeah, that looks pretty good. Who knows? Let's just see if this does anything resembling what I want. Excellent. No, it doesn't at all. Max arg is an empty sequence. Oh, wait. What? Do we have to input first? Oh, shoot. Another thing that we have to do. Darn. Here, if x equals -1, so that this is that score condition, and y equals 0, score equals I, and we're gonna store the score up here, and we're gonna also print it out here, I think. Score. Okay, that's interesting. Let's just print the entities, see what happens. Yeah, there's a ton of entities. There's an absolute ton of entities. So, what's the deal? Oh wait, oh shoot. We don't want that third entity. Or the not third entity, last entity where it's a -1. We wanna break out of that. Entities.keys? What are the keys? That should be, yeah. Wait, look at this. Let me scroll up. Oh, it just dict keys. Yeah, okay, so we should be able to go through all of the keys. What's wrong with this? Map object. Oh my goodness. Of course it's empty, because we took it up by the last generator. So yeah, these min and max consume the generators, yeah. And when the generator's consumed, you don't get it back, so. Oh my goodness. Look. How does this work? Okay, so what do I do here? Tilt it to the left. Provide -1. Oh dear. I guess I'm not supposed to clear these. That. Cool. Oh, this is so good. Okay, so 0 for neutral. Oh, this is a ton of fun. Oh, okay, so I gotta make my mechanics way, way better. I guess WASD will work. Yeah, let's just use WASDA. So W is going to be no wait, good grief, W is the up. ASD, so A is going to be -1. I think I can just do this, right? What I'm asking you for, right? S is 0. D is going to be 1. No, let's use Vim bindings. H and L. Oh wait, no, this will be L. And we'll do I'm trying to think of Q, I guess. Oh dear. Oh, I lost. Okay. Oh my goodness. Okay, that's really annoying. In, you know, dir equals, so I don't know if you saw that, but like it couldn't find my input because I didn't actually input anything. And that's going to be really problematic if this game is going to be any good. So, oh, I wonder if, okay, how do I just get a single char? From std in Python. I feel like I should know this, but I really don't. Okay, I'll let that open for a second, and while I do that, I'll put this in a while loop. And put this in a get. And then sys.stdin.read1. That sounds like what I want. That didn't seem to work. Sys.stdin, single line, single char without enter? Grasping at stars. Maybe this isn't really that easily. Oh, here we go. Oh, I don't want to do a curses GUI. Yeah, no, let's just go back to input. That worked fine. Oops. Yes. Bounce around there. It's nice that it no longer crashes if I accidentally press enter before pressing an input. Okay, so I think I need to move the paddle again. You know, okay. You know what else needs to be this? 0 is empty string. That's unfortunate that I can't, restart this. The physics in this game is pretty terrible. Guess that's what you get for writing an Intcode program to do this. Gotta start moving my paddle. Oh no! Shoot. Well, guess we're playing again. And again. I don't know how big this paddle is supposed to be. Oh! One character, apparently. Wow, I am awful at this game. Okay, let's just, dear. I guess we'll just keep playing. Until I win. Okay. I have to clear all of these? Wow. Oh, wait a second. Can it come at an angle? Is that how this works? Maybe that's how this works. Okay, so that's definitely the strat, to get it over to this side and have it just bounce in and destroy everything. Oh, okay. Yeah, I don't understand how the mechanics of this game work exactly. Because if I go here, then it bounces that way. Like, how does this paddle work? I don't know. Oh no. Oh. That is disappointing. Okay. Playing again. Maybe I could write a program to do this game for me. I'd probably be better at it then. Oh, is it a glancing blow that it... I don't get these mechanics. Like, does the paddle work? Like, how does this paddle work? Maybe I should do an underscore and make this a bigger O. Oh, I can write a program for this. I just need to know where the O is. Oh, okay. I'm seeing it. The strat here is that you just have to be at least on the same page. Oh, okay. Clearly I need a robot to do this for me. Okay. So basically the strategy is you want to always be over the O. So if you're to the left, wait a second. So how does that work here? Yeah, at each stage, if the O is to the right, then we have to move to the right. See? And if the O is to the right, left, we move to the left. If it's even, then we stay even. I see it. Okay. Okay, so I can automate this now. So I guess the way to do this is we're gonna go through, find the paddle, and find the O, right? The ball, and we need their X coordinate, I guess. Entities dot items. Okay, so the items X is, okay, so we really need to reverse this map, but let's just do X, Y, comma. Okay, so the entities, what are they formatted as again? X, Y is the key, and then I is the ID in entities. X for x, y, and integer set items if I equals the ball. So 4. Zero, I guess. So the first one, ball. So ball and then paddle is 3. If ball x less than paddle x, direction equals -1. If ball x equals paddle x, direction equals 0, else direction equals 1, and then we return the direction. And I'm gonna just do a sleep here, so we can actually like see this in progress to make sure it's working. Time to sleep 0.25 seconds should be fine. Oh look, it's playing the game for me. This is way better at it than I am. Oh, look at this. This is so brilliant. Okay, let's reduce this. This is a bit slow, to be perfectly honest. 0.1. Okay, I like this a lot. I really like this. You kind of had to like either be really intelligent and see that you were supposed to automate this game, or you had to play this game yourself. And I'm bad at playing games, so even if you look at it moving around there. I'm good at writing code though, so look at this. It's playing it. This is brilliant. Oh, I wonder if you're supposed to do this. I guess they kind of did design it such that you could. Like, the mechanics are easy to make an AI for this. The funny thing is, when I was playing, I was like doing this exact thing. I was like, oh, this is really annoying. I can't figure out how to play this. Okay. This is tons of fun to watch. And to think, all of this is running on an Intcode computer, or emulator. This thing is literally just emulating a Turing machine. Basically, it's also written in Python, so the Intcode machine itself is pretty slow. The output is slow. Everything about this is slow, but it's still better at it than I am. I wonder if it's going to clear everything. That's going to be really unfortunate if it can't. If it can't, then I'm just going to cry, honestly. I guess I can maybe do some sort of like... I don't know what I could do, to be perfectly honest. Make the AI smarter? That's kind of always the answer, isn't it? I don't know that it can be that much smarter. We'll just let it run its course, though. See, the other option that I have here is to just decompile the source code and see. There we go. Okay. It looks like it's doing pretty well. Like, it might just do it. I'm just gonna leave this. Let it go. I'm not gonna talk very much because I'm probably just gonna hopefully figure out how to speed things up in Kden Live. So basically, as long as it doesn't loop, we should be okay. I guess loop twice is really the problem, isn't it? Ooh, we might have... Oh, look! Cool. It didn't loop. Alrighty. I think it's gonna do it. Man, this computer really has fast reactions. I must have coded a good AI. It just can't get into a steady state. That's all that it cannot do. And it is not. I'm still safe. It's always concerning when it kind of goes up and down and doesn't do anything, but it's still not in a steady state. You know, I bet the score is like that last number in the input. That's going to be really annoying. This AI is pretty terrible at this game. But so was I, so who am I to judge? Okay. We'll just let this play out. Come on, come on, come on. Get the last ones. You can do it! Oh. Come on. Yes, bounce. Oh. Don't keep bouncing around it. Hit it. Oh no. Is this a steady state? I can't tell. Apparently not. Look at that. Got him. Got him. Look at this. It's gonna do it. Come on. Come on, little AI. I don't know why I'm talking to it like it's my kid. Basically is. It's a better version of me. Oh, it almost... You're almost there. Come on, come on. Well, the good thing is I don't think this is steady, so we should be okay. Bounce up, yes. I don't know why I am so involved with this. It's not even that stressful. Okay, it's extremely stressful. It's so close. Oh. So close. Got it. Oh my goodness. Oh my goodness. It did it. It's so much better at this game than I am. Alright, submit this thing. Darn it. Wait. What? Oh! Shoot. Shoot, you know what? So, I think the oh, okay. Darn, I think I need to print the score again. Yeah, that's what it is. Okay. I think all I need to do is do another print entities and wait for input. Really just run AI. that should be fine because it doesn't actually wait for input anymore. And I'm gonna get rid of this whole, sleep thing. Or make it really short. Look at it. Look at it. It's so good at this. Look at how fast it is. It's almost like it, knows what's going on all the time. Okay. Here we go. Come on. Last bit. You know what? This is too slow. Get rid of that time.sleep. And honestly, we can get rid of this printing of the board. This entire thing. And just give us the score at the end. Yes! Haha! Good job, AI. Oh, I don't even need this anymore. That's really funny. Yeah, literally all that matters is the position of the ball and the paddle. And you can play this game yourself. Or you can automate it. Are these supposed to be like planets? Is that what this is? I guess I haven't ever really... Because these have rings, yeah. Maybe we're on Saturn. Alright, well, that's a wrap, I'm going to call it. That was a ton of fun, actually. Had to implement this whole game thing and figure out how to beat it. Alrighty. Well, if you liked it, like, subscribe. I'll probably do 14 as well. So, peace.